Hi and welcome to this section where we would like to look at quadratic equations. So this is chapter 10 of our resource book, Basic Engineering Mathematics by John Bird. So far we have looked at linear equations, i.e. equations in which the highest power of the unknown was 1. So now, to solve an equation which has the highest power of the unknown as 2, such an equation which has the highest power of the unknown as 2 is the quadratic equation. The quadratic equation takes the form of this form here. Okay, y equals to ax squared plus bx plus c, where a is the coefficient of the square term, b is the coefficient of the term in x, the linear term, and then c is the constant. Okay, so if y is equals to 0, then we are solving the quadratic equation ax squared plus bx plus c equals to 0. Now when we solve for this, which is simply meaning that we want to find the roots of this equation here. Okay, and what are the roots? The roots are the points where that equation is cutting the x-axis, or which we already know is the line y is equals to 0, i.e. y is equals to 0. So we shall later on see the shape that is cut out by such an equation here is a parabola. Okay, depending on the direction depends on the signs of the coefficients here. Okay, so this parabola here, the point I'm trying to make here is that the parabola here, or the curve that is, the curve that describes this quadratic equation here, where it cuts the x-axis, okay, or the line y is equals to 0, i.e. we're interested in that particular x value here. Maybe we can call it x1, of course y is 0, and then here maybe we call it x2 and y is 0. That is the root of our equation, and that is going to be the solution here. So this equation here will have two solutions, and there are two, we shall look at three ways of solving or finding the roots of this equation. One, we shall look at factorization where possible, and then two, we shall look at completing the square, and then three, we shall use what we call the quadratic formula method. Then 4, we shall also look at the graphical method. We shall try to graph them also and see. Okay, so for now we are going to start with the solution of a quadratic equation by factorization. So a few notes here to see is that this expression 2x plus 1 to x minus 3, okay, if we simplify it using the techniques we have already known or learned, we should be able to get 2x squared minus 6x plus x minus 3, okay, which should reduce to 2x squared minus 5x minus 3. But now the reverse process of moving from this, expression here, 2x squared minus 5x minus 3, to this form here is what we call factorization. Okay, so we shall have this form and we try to reduce it to this form here, okay, where we have powers of 1 here, linear, where these terms here just have, highest power 1, highest power 1. Okay, when the power has been reduced, okay, and it is not 2 anymore, but we have reduced it by at least 1. So this is what we are going to look at as factorization. For example, we would like to see how we factorize 2x squared minus 5x minus 3 equals to 0. Okay, not just factorizing it, but solving it by factorization method. So we have already seen that we can reduce this. We shall see how to factorize. Let us assume that now we know how to factorize. So we have already seen that this expression here can be written in the form of 2x plus 1 multiplied by x minus 3, and we have equals to 0. So the idea here is that if you have the product of two numbers, which is 0, of two terms, you have the product of two terms as 0, that means that either one of these two terms is 0. So either 2x plus 1 equals to 0, which implies that x equals to negative 1/2, or we have that this is what is 0, so x minus 3 equals to 0, implying that x equals to 3. So then we have that the values of x are negative 1/2, it satisfies this, and also the value of x is, the other value of x is 3, and also 3 also satisfies that, okay, equals to 0. So in the next video we shall now look at a proper procedure how we can factorize these expressions.